let's go over this real quick. So this is the first one of these that you have gotten from me so far this year, so you might be not that familiar with what I'm expecting here. The first thing I want to make sure that you're aware of is that you're not supposed to be doing a whole bunch of in-depth calculations for this type of worksheet, okay? Generally speaking, this type of worksheet, I give you 15 minutes to do it in a group, right? And you have access to your notes. And if you were to successfully and appropriately complete these questions, you do very little calculations, but you would be applying concepts and the basics of whatever equation that we're dealing with. And so if you're kind of going through these worksheets in the future, right, really when we get to the kinematics, it'll kind of ramp up. And you're thinking to yourself, I don't have any numbers to work with. I don't have any numbers to plug in. We're not supposed to, right? So when I say like, hey, what's the acceleration in this situation? Well, you rearrange that equation to solve for A, or acceleration, right? That way, without having to do a whole bunch of like plug and chug in your calculator, I know that you have the skills to rearrange that equation on whatever assessment that I actually give you, right? But you don't have to go through all the extra calculator work. You're just using the concept or the equation. All right, so talk about displacement and velocity. A minivan travels along a straight road, right? No turning. Now, do not get confused. This graph going up and down, that does not mean that the direction is changing, okay? That's not what that means. This is a straight road. We're not going left. We're not going right. That means the only way that we can go is forward and backward. It initially starts moving toward the east. And so the initial movement is east. Now, on this graph, which way is east on the graph? Up. Okay. The position? Right? Position is on the y-axis here. The x-axis is time. The x-axis is time. Okay. And we'll get to this as we go. So, use the information in the graph to answer the questions below. So we're going to be referring to this graph each time we need to answer a question. So number one, does the minivan move to the east? If so, during which time intervals? Well, yes, we can see that starting here at T1, we're moving up the y-axis all the way until we get to T4. So, yes. From T1 to T4. And, again, we see this little stretch right here where the minivan is moving to the east. Okay, again, moving up the y-axis. And T6 to T7. And that's all I need from you. I don't need anything else fancier than that. Number two, does the minivan move to the west? If so, during which time intervals? Yes. From T4 to T5. Again, from T4 to T5, we see the overall change in position is moving down the y-axis. And we've already established that moving toward the east is up the y-axis in position. And so as we're moving down the y-axis, that must be to the west. Number three, if the minivan's speed between T1 and T2 greater than, less than, or equal to its speed between T2 and T3. Okay, so we are comparing T1 and T2. So we're comparing from here to here with T1 to T3. Now, as we're getting ready to move into acceleration, it's important to note that from T1 to T2 and from T2 to T3, there is movement. You can tell that there's movement because there is a change in position. Okay? Now, this question is about their speed, the rate at which their position is changing. And so we can approximate that by the slope of this line. We can see that the slope of the line between T1 and T2 is a steeper slope, right? There's more rise compared to the run than the slope of the line between T2 and T3. So that means that the speed between T1 and T2 is greater than. Number 4, is the minivan's speed between T4 and T5 greater than, less than, or equal to its speed between T6 and T7? Okay, so go T4 right here and T5. So comparing that little jaunt to T6 to T7. Now I want you to pay very, very close attention to the wording here. Speed. Speed, not velocity. Okay, it's just your change in position, like how much distance you're traveling here. And when we look at this graph, you see that we have a steeper slope between T4 and T5 compared to the slope between T6 and T7. The direction here does not matter. This is not a velocity. This question is asking about speed, right? So we don't care about the direction of the slope, right? We just care about the magnitude of the slope. So for number 4, is it greater than, less than, or equal to? Greater than. Number 5, does the minivan ever stop completely? If so, at which times? Now, if we're completely stopped, not moving, can there be a change in position? No. So on the graph, we're going to look for chunks of time where there is no change in position. Now, on this XY graph as it's set up, that means that we're looking for a flat line, right? There's no change in Y. So a flat line that's parallel to the x-axis. So we look for those, and we see it's between screen. Yes. From 0 to T1 and T5 to T6. Right? These are these portions where there's no change in position, because again, position's on the y-axis, there's no change in the y-axis, so there's no movement here in these two spots. Number 6, does the minivan ever move with a constant velocity? If so, at which times? For this one, you have a lot to choose from. Okay, so any time in the movement of the minivan where there's no change in slope. Okay, so any time where the slope remains the same. So I guess I'll put that there while I write. So yes. T1, T2, T2, all the way to T4. Again, that's just the same slope right there. Even though there's a T3 in the middle, it's the same slope. There's no change. And then T4 to T5, right? Because it's, yep, T4 to T5. And T6 to T7. And lastly, number 7, what is the total displacement of the minivan during the trip? Total displacement here. So again, where is the minivan at the start of the trip? Right here. Where does it end up? At 0 meters. So the total displacement, this thing has moved 5 meters. Now, as I've written it right now, it's incorrect. What am I missing here? The direction. So quantitatively, like numerically, how would I represent this moving west? Negative sign, right? Because moving down the y-axis is considered negative by sign convention. Or, alternatively, and just as accurately, you can write 5.0 meters west. They're just as good as one another. This one's going to be more useful when you actually go to do calculations. Yeah, but when you're just like talking to people, this is how you would say that.